Welcome everyone to the Star Party for September 11th, 2021. My name's Aaron Bannister and I'll be hosting this evening. We've got a great show for you today. We've got some folks from the Nanaimo Royal Astronomical Society to tell us about their programs a little further up the island. And then we've got Margie to talk about women in astronomy up to the 1900s. After that, we've got Ask an Astronomer. So please bring your questions, try and stump us. And then finally, as we end the evening, we'll have electronically assisted astronomy. Some of our observers showing off some of their fantastic pictures since it is less than clear out today. We finally have some nice rain. To start off, I'd like to take a moment to acknowledge that we are on the traditional territories of the Coast Salish and the Kwanghan-speaking peoples who are the custodians of these lands and waters. This area has long been the gathering place of the Songhees, Esquimalt, and Saanich nations, long before the arrivals of Europeans. We are grateful to have the opportunity to live, work, collaborate, and learn here, and we respect the continued connections with the past, present, and future in the ongoing relationships with Indigenous and other peoples within the British Columbia community. We invite all attendees tonight to reflect on the relationships you have to the communities that inhabit this land and share the night sky and wonder. If you are watching us on YouTube tonight, we would love it if you could click the like button and hit subscribe. You'll get notified of our future star parties. We're changing up the schedule a bit as we move into the fall, and hopefully we'll have some online parts of our in-person star parties once those start up again. Still no news on when that's going to be, unfortunately. You can also find us on pretty much all the social medias at FriendsDAO. So that's Instagram, that's Facebook, except on YouTube where we are Center of the Universe, I believe. Let's see. If you would like to help us out, we are looking for memberships. We are a member-supported organization. So if you'd like to support us either with a membership or donation, you can visit centeroftheuniverse.org and become a member there by clicking on the membership tab. Members get access to the Zoom chat where you can see us a few seconds before the folks on YouTube and interact directly with us through the Zoom chat. We're also looking for volunteers. We still don't know quite when we're opening to the public, but we have a lot of projects underway to get things started and brighten up the gallery, add a few new exhibits. So if you'd like to get involved with that, again, you can head to centeroftheuniverse.org and click on the volunteer tab. If you're coming with a question about life, the universe, everything, what we had for lunch, maybe not that one, you can add that into the YouTube or Zoom chat for our Ask an Astronomer folks. They'll be coming in after the talks. And if we have a few questions in the chat to start with, they can have a chance to do some research and make sure they give you the best answer they can. And with that, I'm going to turn, come on. I'm going to introduce our folks from Nanaimo.
Actually, we're going to have, I think.
No, sorry, Dawn is starting with What's Up in the Sky. That's right.
Okay. Hi, everybody. And my name is Don, and I'm based here in Victoria. I'm from Nanaimo, as a matter of fact, grew up there. So I'm kind of eager to hear about everything that's going to be said tonight. And what I'm doing here tonight, of course, is I'm just maybe telling you a couple of things that you might not already know about what's coming up in the sky in the next couple of weeks, and maybe provide a little bit of a tiny bit of an astrophysics background too. So I'll just give you a little bit of a rundown on sunset and sunrise times and so on. So sunset is now at 7:34 p.m. here in Victoria, with full darkness from 9:22 to 4:55 a.m. and sunrise is at 6:47 a.m. And Venus is still visible low in the west after sunset, as you can probably see on the screen here in the twilight. And you may have noticed the beautiful crescent moon in the southwest last night. So that was really quite a sight. First quarter moon is on Monday, September 13th. Full moon is on September 20th. And this is the harvest moon, also known as the corn moon or barley moon, and by various other names. all of these names are strongly associated with the end of the summer harvest, and the full moon in September is significantly higher in the sky and up longer than midsummer months, which allowed late working harvesters to continue working by moonlight in the days before artificial light. So hence the name. So the harvest moon also nearly coincides with the autumnal equinox this year, and that's when the sun crosses the celestial equator on its apparent journey south, and that takes place at 12:20 p.m. on Wednesday, September 22nd. And I don't know about you, but I really welcome the beginning of fall after the excessive heat of the summer. The cooler temperatures happen as the sun heats the ground for a shorter period each day, and the sunlight must also be filtered through more air. And so even at equinox, the sunlight at noon on a clear day here must pass through about 37% more air than at noon on the summer solstice. And there's always a lag of a couple of months, however, as the surrounding water takes time to cool off. And so the name equinox refers to equal day and equal night, but you purists out there, and I'm thinking of you, Aaron, will say, hang on, that's not quite right. So part of the reason is due to refraction, as the sun pokes this disk above the horizon a little earlier at sunrise and sets a little later than it would be if there's no air surrounding the Earth. And we also have to consider that sunrise and sunset are defined when the first bit of the disk of the sun rises and the last bit sets. So on equinox, the day is actually about 10 minutes longer than the night, despite the name. So true equal day and night is therefore a few days later than equinox, and it occurs around the 25th. And you can call this equilux if you like. That's the name that's typically given to it. And there's a nice essay about this on earthsky.org, and I'm going to post that on Facebook in the coming weeks. And I'm just going to shift my screen here on the side. I haven't quite figured out how to juggle screens at home yet, so just bear with me for 2 seconds. And so despite our movement into a new season, the summer constellations, the Milky Way, still linger after sunset. And so why is that? It's because we're actually moving, while we're actually moving around the sun and they drift a little further west every night, sunset is also getting earlier. As a result, at the same time after sunset, the constellations are still in much the same place. And the reverse is true in springtime, where the winter constellations are wiped out much more quickly after the equinox. And that was frustrating back when Betelgeuse had faded and we all wanted to keep watching it, of course. So what this means is that fall is a bonus time for astronomers. You get more time to check out summer constellations and earlier in the evening. And you also get to preview winter constellations late at night. And as I noted in the last talk, the Pleiades rise in the late evening just after 10 p.m. now, and the winter constellations are happily placed well in the dark hours before sunrise. And if you don't need much sleep, kind of like me, and have a good memory, unlike me, try comparing the summer sky in the evening to the winter in the pre-dawn morning. You'll notice that the stars in the winter sky tend to be brighter, and that's true for a simple reason. In the winter sky, we are looking towards a clump of the Milky Way that's by and large closer to us, and because it is closer, the stars appear brighter. And you might also notice that the winter stars appear more colorful. Because they're brighter, you can see their colors more easily, as we need a fair bit of light in order to activate the color sensitive cones in our eyes for them to work and for us to sense the colors. So that's a little project for you folks if you can do that on a single night. So that's it for me this week. Thanks for listening, everybody.
Thanks so much, Don. I love the term equilux. That's fantastic.
Isn't that great?
Yeah.
Sounds
right.
like a vacuum cleaner, I know, but Calvin's nodding vigorously.
Yeah, that's what I thought.
Excellent. All right. And now we'll turn over to our folks visiting us from Nanaimo. So first off, we have Tony Puerzer, the Vice President of the Nanaimo Astronomy Society. Tony's a full-time professional photographer and part-time amateur astronomer. His lifelong interest in astronomy outreach and education have included 5 years as a lecturer at H.R. Macmillan Planetarium in Vancouver. Fantastic place, I love it there. And from 2016 to 2019, he authored the popular Capturing the Universe column for Sky News magazine, which is published by the Royal Astronomical Society of Canada. He's currently contributing articles for the ongoing First Exposure column in Sky and Telescope as well. We also have Janeane Macgillivray, the Director at Large of the Nanaimo Astronomy Society. Janeane's astronomy light bulb went on at the 2009 International Year of Astronomy Star Party, co-hosted by RASC Victoria and the Cowichan Valley Starfinders. The fellowship among amateurs and collaboration between amateurs and professionals continues to appeal to her. She volunteered as an assistant to astronomy educators in K-12 classrooms 4 different times during the week-long Journey Through the Universe Astronomy Outreach and Education Program on Hawaii Island. And that's where I had the pleasure of meeting her the first time. I was down in Hawaii for one of those Journey Through the Universe sessions, and we had a blast. Drawn to multidisciplinary endeavors since 2017, she's reveled in the role of speaker recruiter for the National Astronomy Society. Is that NAS?
Nanaimo Astronomy Society.
Nanaimo Astronomy Society, of course. By offering presentations on a wide variety of astronomy topics and with outstanding press coverage by Nanaimo News Bulletin reporter Chris Bush, she's proud that the Nanaimo Astronomy Society is contributing to the public understanding of science. I want to thank you two so much for joining us, and I'm eager to hear about the work the Nanaimo Astronomy Society is doing.
Thanks, Aaron. I'll just share my screen and so is that all good for people?
Yes, we can see it.
Awesome, yeah. So why are the Friends from the Mid-Island presenting to the Friends of the Dominion Astrophysical Observatory? Well, we're part of a worldwide community of astronomy enthusiasts, amateur astronomers, or maybe even astronomy hobbyists, we've been called. And there are millions of us worldwide, including many on Vancouver Island. In 2019, NAS, or Nanaimo Astronomy Society, realized it was perfectly positioned mid-island to bring together the island's 4 astronomy groups and 2 astronomy businesses for an evening event called AstroFest, open to the public. The groups were the FDAO, the Royal Astronomical Society Victoria Centre, Cowichan Valley Starfinders, and they brought along the Shawnigan Lake School Observatory as well. And the 2 businesses, Island Stars Observatory on Horby Island and Quarky Science from Victoria. So I'm just going to play this video now of AstroFest. It's about 50 seconds long. And we were ecstatic that 120 people showed up to share our passion for astronomy. We really didn't know what to expect. Friends and connections were made among the groups I mentioned, and we're grateful for this invitation to speak at this FDAO event that continues this collaboration. AstroFest made us realize even more how diverse the world of amateur astronomy is and how interested the public is. And we use this knowledge to shape our speaker program that I'll talk about in the second part of this presentation. You might recognize a few people in the crowd there. That's at our meeting place at Bevan Park in Nanaimo, big public meeting place. And now over to Tony to tell us how we got here with a bit of Nanaimo astronomy history and highlights of some of our other outreach activities.
Thanks, Janeane. Boy, seeing that video from a couple of years ago, pre-COVID, really makes me feel that I want to have those good old days back again. But anyway, let's talk a little bit about the history of the Nanaimo Astronomy Society. We started out as a very informal group of visual observers and astrophotographers that met at a local facility. And in 2004, we were incorporated as a society, and that's when we became known, instead of as the Island Stargazers, as the Nanaimo Astronomy Society. A few years ago, the board made a decision to keep our membership costs on the low side to make it accessible to as many people in the local community as possible. And we decided we would rather have a larger membership with lower cost dues rather than a small membership with high cost dues. We now have over 90 members in the society, which is pretty good given what we've been going through with COVID and those sort of things the last little while. And I would say rather than 90 people that are hardcore astrophotographers or visual observers, my impression of the people that show up at our meetings is that they're sort of a general science enthusiast type with an interest in a specific area of astronomy or space science. So the programming tends to address that sort of general interest area, although we do cover a lot of different topics. And Janeane will talk about the meetings and things like that we do and the kind of topics we cover. But I thought I'd just spend a few minutes to show you some of the things that we've done in the way of public outreach, some of which start on local media stations. As I'm sure some of you in the audience know, when something like Comet Neowise or something appears in the sky or there's an eclipse, the local media will look for someone locally as a sort of subject matter expert. And so we've been on Shaw TV locally, as Janeane mentioned in the newspaper. I've also, like when I went down for the 2017 solar eclipse, I was on CBC radio, kind of reporting from down in Oregon. So we tend to bang the drum for the Nanaimo Astronomy Society on the local media. And that includes print media. And as Janeane mentioned, we're very lucky that the Nanaimo News Bulletin has a terrific supporter in a reporter named Chris Bush, who is an astronomy enthusiast. And he often will publicize our meetings or our outreach events, such as a few years ago, there was a big lunar eclipse just at sunset. And it was a beautiful evening, and we had a huge crowd show up thanks to the media coverage down at Departure Bay Beach. I was actually kind of shocked when I saw how many people showed up. It's people all the way as far as you can see along the edge of the beach there. And we had a whole bunch of telescopes that we brought out for people to look through. And a lot of them were trying to take cell phone photos through them, of course, including our big 20-inch telescope that one of our members, Bill Weller, created for the society to use. So those are terrific evening type of events. We've also had 2 solar eclipses that we've had public outreach events with, at least since I've been part of the Nanaimo Astronomy Society. And it's great to see people just wandering by down at Mafio Sutton Park and popping on the eclipse shades to take a look at the eclipse visually, or through one of the many telescopes that we set up that had safe solar filters. On this particular eclipse, which was the one before, they were sort of surprised that we were actually looking at an eclipse. They hadn't even realized that one was there. The next one, we'll also do a Canada Day celebration every year down at Mafio Sutton, and we'll get lots of children and families coming, and they're really blown away by the views through the 2 hydrogen alpha telescopes that we have available. From the kids' perspective, again, we do a lot of outreach with the local elementary schools and Boy Scouts, Girl Scouts, Cub Scouts, things like that. And it's just a wonderful way to incorporate astronomy into some of the wider local social events.
And
we have just to jump in, Janeane,
yeah,
sure.
I just want to mention, Tony, like a lot of this, I think these activities are familiar to some of the members of groups that are participating. This is what astronomy groups do the world over, is bring this kind of activities to the public. And it's pretty exciting for both the participants and also the people that do it.
Yeah, this is actually a fun one here. I did a thing where I brought a bunch of different lenses, and we had the kids try and figure out what combination of lenses would make a telescope. And it was kind of fun to watch their faces when they would line the lenses up just right. And then like, ooh, that's really big in there. So it was kind of cool to see that. So I just think I had more fun than the kids did. We also have a medium-term project that we're doing at the Nanaimo Astronomy Society, where we're trying to create an urban star park or some sort of urban star observing area. A lot of the parks that we have around the Nanaimo area close early in the evening and are either gated or you're not supposed to be in there after, say, 11 o'clock. Or the ones that are available just aren't perfect for that. But recently, the Parks Board here in Nanaimo has acquired a piece of land, and we've been working with them to put in some facilities to create an urban star park here in Nanaimo. And so that'll be a wonderful legacy for the Nanaimo Astronomy Society if that all comes together. That's been something we've been working on for many years now, but it's looking like it's slowly coming together.
And I think a lot of people are actually going there now with their telescopes, even though it's not a designated area.
Right. And that's a good point. I've seen some people posting those things on Facebook. As a matter of fact, a good segue to go on to the next one is that we sort of have a parallel astronomy club that's developed on our Facebook page, where I think we've got almost an order of magnitude more people that participate in our Facebook page than our actual members. But it's become extremely active with people posting astrophotography and various news articles and things like that. And you're right, I've seen Dr. Greg Arcos, one of our local astronomy professors, post a lot of things where he's actually taken photographs from the site of what should be the future star park. So these are all like really exciting things that have been happening over the last few years with NAS. Now, Janeane, have I forgotten anything at all anything else that we do at NAS or not?
I'm just gonna say maybe the speaker program.
Oh, right. Okay, that's the thing you're responsible for. Okay, why don't I hand that over to you then, and you can talk about that.
Oh my goodness, thanks, Tony. And I do want to say that, of course, as astronomy enthusiasts, we want to have fun too. And being on the board has been so much fun, and collaborating with people like Tony has been so much fun. Even though I must say, I do think there is an actual truism, and that is men are from Mars and women are from Venus when it comes to working together. So what about our speaker program? So our very popular public in-person monthly meetings featuring guest speakers was suspended in March 2020 because of COVID. Our members have basic to advanced knowledge of observing astronomy and related sciences, astrophotography, and space exploration, and gave short presentations before the guest speaker at every meeting. We were attracting 50 to 60 attendees, sometimes out to 100 in our facility, Bevan Park, this big social center. And we use the speaker program to aim to address the diverse interests of astronomy enthusiasts and grow these interests at the same time. In other words, we do want to help people sort of stretch their own interest areas. We started offering our speaker programming online to members only in April 2020, and last fall introduced a more informal members night midway between monthly meetings. And that was modeled loosely on Royal Astronomical Society of Canada Victoria Centre's Astro Cafe model. And they members meet every Monday evening and have a very diverse topic areas. People can speak on a number of topics and for various time periods. So we really like that idea and kind of morphed it into our members night in between our monthly meetings. And like all of us, as Tony said, oh, don't we all want to get back to the good old days? So back to that diversity theme again about interests. So just wanted you to think about what different kinds of astronomy enthusiast are you? And I'll just mention a few. A science enthusiast that Tony mentioned, a lot of our folks they're interested in astronomy in a general way. They might consume astronomy content online or go to our meetings, maybe attend public lectures like this. Or maybe we know there's a lot of observers. That's kind of the traditional astronomy enthusiast. who view the night sky for your own satisfaction. We really know about astrophotographers these days, and perhaps even astro-sketchers. Some enthusiasts take courses. I know Lori just finished a course at UVic and maybe is about to take more. Perhaps you're a traveler who's gone to different space centers around the world, dark sky preserves, or maybe you're an eclipse chaser. You could be a citizen science contributor who researches and contributes to our knowledge of celestial objects and phenomena. And I know for sure I'm not one of these last three. I'm not an equipment maker. I'm not an entrepreneur who has a business, but oh, actually, maybe I am one of these. I'm a content creator. So since my astronomy light bulb went on personally in the International Year of Astronomy in 2009, I've explored what kind of astronomy enthusiast I am. Many astronomy telescope owners will tell you their most satisfying moments are at public viewing events when people are bowled over by their first view of Saturn and the rings of Saturn, or Jupiter's moons, that famous so-called Galileo moment. Not me. No, I don't. That doesn't do it for me because I don't even have a telescope. I'm a content creator and organizer and get so much satisfaction out of the Nanaimo Astronomy speaker programming role. And I use my experience as a member of NAS, FDAO, RASC Victoria, Cowichan Valley Starfinders, and my knowledge from visiting astronomy facilities around the world and by volunteering for astronomy education in Hawaii to inform my role here. So our board, our Nanaimo Astronomy Board, in 2019, we adopted these 5 topic areas to guide our program and to really see if we could address most of those astronomy enthusiast interests we just talked about. So science. So that involves astronomy, astrophysics, astrobiology, astrogeology, engineering. And I'm going to go through these later one by one. Astronomy facilities, they may be on the ground, like facilities in Hawaii or in Mauna Kea, or they might be in space. Astronomy and space history. We've had speakers on the 50th anniversary of Apollo 11, for example. Observing, number 4, how-to sessions. And we've dedicated our June meeting to that very subject, as well as other times throughout the year. And then finally, astronomy tourism. And we've had amazing presentations from Greenwich Observatory in England, the Canary Islands, national tourism, such as the Dominion Astrophysical Observatory in Penticton, and local, and I'm going to call that AstroFest, I'm going to call local tourism. I do want to make a comment about speaker diversity, because we recognize that speaker diversity goes hand in hand with topic diversity. While we haven't adopted a formal policy, we do consider this when choosing speakers. So I'm going to describe our different sections of our speaker program in more detail, but I do want to acknowledge 2 people and organizations here who are at the core of what we do through our speaker program. So you can see the byline here, Chris Bush, Tony mentioned him earlier. The bulletin has been absolutely stellar in covering our press releases we send to them about our monthly meetings. Chris is interested in astronomy personally and science generally, but the paper itself has been enormously supportive in his work and often covers in addition to his work. We have had coverage from other print media outlets and online, but really our liaison with Chris has been the key to contributing to the public understanding of science. Without this aspect, it would be very different in terms of our reach. And I've taken screenshots of the bulletin articles, including the headlines. And you can just imagine seeing that in your local paper, headlines about science that really say, this is important. We've got some way for you to learn about science in an informal way in your own community. And everyone is welcome. So I do hope you'll pay attention to both the images and the headlines in that regard. So the second person who is key to our endeavor is James DeFrancesco. He also does presentations for us and for FDAO and RASC, but he's the director of the Dominion Astrophysical Observatory in Victoria. If you don't know what that is, it's part of the globally important National Research Council, Hertzberg Astronomy and Astrophysics Research Centre in Victoria. I know that's a mouthful, but we call it Hertzberg for short. And that's where we recruit many of our speakers from. We also recruit from other organizations such as UVic, but we don't have a particular liaison with them, liaison person. We contact them individually, but James has been absolutely key, and I know he's been key to other groups in helping us bring science to Nanaimo. So topic number one, I wanted to give you some illustrations about. So science, we had Samantha Lawler, a Plaskett Fellow from Hertzberg, talk to us about the possibility of there being a ninth planet in the solar system. What? Yeah, but she showed us her research and made an argument. This is Guillaume Thomas. He talked to us about dark matter, and we also really do want to support postdocs there at Hertzberg. So we have a few folks like that come up to talk to us. We had these three students talk to us from Nanaimo District Secondary School. They were part of the Student Spaceflight Experiments Program, which is an American program that opened up the competition to Canadian schools a couple of years ago. And schools across both countries can compete to have their science experiments, I think it's grade 11 and 12, flown to the International Space Station. And then they get to go to the center in the US to present on their findings. So the point I want to make here is that we are trying to have include as many youth as possible in our speaker program. And it's a two-way thing. We learn from them, and we support them in doing that, but we also learn from them, and it's a two-way, very much a two-way synergistic kind of a relationship. They sent worms to space, by the way. We also had Mi'kmaq Moons present from, they zoomed in from Nova Scotia during our COVID period here. Dave Chapman from RASC, Nova Scotia, and Kathy LeBlanc from the Acadia First Nation presented on the two-eyed seeing approach of the lunar cycle that's a basis of so many First Nations experience with the sky. And so that presentation contributed to our public understanding of different ways of knowing about the sky. I view it as a different form of science. So this is John Willis from UVic, University of Victoria. His presentation on the search for life, astrobiology, was just amazing. We had over 100 people. And the reason why we had over 100 people, because we also recognized another opportunity to collaborate. Because his presentation was partially about the moons of the solar system and the oceans on them, but it was also based, informed very much by his knowledge of the Earth's ocean. And he had applied to become a science communication fellow on the exploration vessel Nautilus. You may have heard of it. It's a globally known research vessel. And that vessel in 2017 went off the coast of British Columbia and down to the Baja to investigate various phenomena and do science. And he was a fellow on that trip. So I approached the Pacific Biological Station, which is here in Nanaimo, through a contact and said, hey, do you think any of your biological station folks would be interested in this presentation? And sure enough, a dozen of them came. And also we invited the Vancouver Island University Earth Sciences Department, including students and faculty, and another dozen of them came. So we did have standing room only at that presentation. Just on the theme of collaboration again, we collaborate, NAS collaborates with Vancouver Island University sometimes, and we brought in Colin Goldblatt, professor from UVic, a while ago to speak to on planetary atmospheres. And of course, he also used the Earth as an illustration to talk about planetary atmospheres on other worlds. The cool thing about that was we liaised at VIU at the university with a student group active in climate change in the schools, in the K-12 system. And it was wonderful. We were able to have dinner with them right before the presentation and make those connections between young university students, activists, and NAS. And back to our monthly meeting here. This is Lisa Locke, an electrical engineer from Hertzberg. And just want to remind us all when we get back to this that at the break and after the presentations with guest speakers, the presenters are usually more than excited to talk to members of the audience. And here Lisa is showing us the array that she designed to help astronomy facilities better see the night sky. So on to the third area, facilities. Oh, sorry, second area. This is Gerald Skiven from Hertzberg Astrophysics. He had a key role down at ALMA in Chile, the Atacama Large Millimeter Array. Here he is in front of one of the arrays. And of course, this is our favorite, local boy makes good, Cam Whipper. He presented to us about the Canada-France-Hawaii telescope, where he's worked for several years now. He zoomed in from Hawaii during our pandemic time, and it just has, as everybody knows, it's given us a wider geographic reach for our speakers. Speaking of far, far away, this is Pranvera Hyaceni, who actually zoomed in from California, where she's starting her master's program in astronomy, but she actually was a contact that Bill Weller had, one of our astronomer on our board of directors. And Bill was following her on Facebook, and she is single-handedly creating astronomy outreach in Kosovo, that war-torn country. She wants to be an astronomer, and she wants everybody else to get on board too. So yeah, we asked her to present, and through the magic of Zoom, there she was. And a few people from RAS Victoria were special guests to our meeting, even though it's members only. But I think everyone can agree, she just made our hearts soar about astronomy. She, you know, to be getting to have nothing, like no telescopes, and then starting to, you know, make connections with American groups. And we saw the video of her getting the first telescopes delivered from a group in the States for sidewalk astronomy. And she said, yeah, she said, I've gone to all these conferences around the world now to see what astronomy is really like, astronomy outreach. And she said, you don't understand, when I see a big telescope like you have at your sidewalk astronomy events, I just can't believe it. So it was that kind of perspective that we really thought was important, as well as her enthusiasm to take into account as we are privileged to be able to do what we do. Astronomy and space history, the third category of our speakers. I just have the one slide. You know Chris Gaynor, probably from former president of RASC National and active historian. We also had Dan Posey from your area talk to us about the 100th anniversary of the Dominion Astrophysical Observatory. The fourth category of speaker topic, observing, very familiar to all of us. This is Bill Weller, I mentioned earlier, and Bill actually is a makes telescopes, and he also holds courses for others on how to make telescopes. And here he is showing us his two mirrors that he's been grinding. This is at our Observing 101 meeting in June, as I mentioned. And this is Bill showing how big his, I think it's his telescope is. Yeah, it's his telescope. We also had Lindsay Melbourne present her master's research on light pollution, and I think some of you may know her down Rask Way. And in June, we also were thrilled to have John Reed zoom in to us from Nova Scotia. He's well known in the Brass Canada community for being a presenter on their various online courses they've been hosting, and also just a general all-around enthusiast for everything astronomy. He wants everybody to be an astronomer. So our last category, astronomy tourism. So we are so lucky that our president, Chris Bohr, is an absolute space science astronaut fanboy. Chris is unstoppable on this subject, and we all benefit. You're nodding, Tony. I mean, I know sometimes you tease Chris about this, but...
Well, yeah, I'm reluctant in teasing him because he always has to wedge in some SpaceX information at every meeting, but I love it. I'm just kidding him.
Well, you know what? It does really create breadth for topics areas, because I probably wouldn't be that interested in rockets and current space activities, but Chris brings it alive for sure. And he's definitely on a mission to get as many astronauts to sign his memorabilia as he can. And there he is with James Lovell doing just that. I think the bigger picture, I think, is at Johnson Space Center. Which is like enormously cool. And then he's been to other space centers in California and well beyond. Thanks, Chris, if you're watching. I guess I had to put this in. This is me up on the summit of Mauna Kea on the catwalk of the Subaru telescope with the Keck telescope in the background. When I went to volunteer in astronomy for astronomy education, of course, there was plenty of time to be an astronomy tourist. And wow, that was just literally, as anybody who's been to Mauna Kea knows, it was an absolute peak experience. And yes, I am on oxygen. I was kind of wobbly, and the guide said, "Oh, you're kind of wobbly. I'm going to give you this little oxygen pack." So I had a great time. And here's this is another international tourism presentation we had. This was Tony, who went to Iceland to photograph the Northern Lights. And fantastic job here, Tony. And I think you also met an Icelandic horse, I believe. And in the photo here, Tony is on the right. Tony also wrote for Sky News, as he mentioned in his biography, and this call, I think your column was called "Capturing the Universe," was it?
Yes, yeah.
Yeah.
So this one, I actually convinced, while I was in Iceland, I convinced the then editor of Sky News to run an article on photographing the Northern Lights, even though we were at the very tail end of the solar cycle. But it turned out to be a whole issue about the Northern Lights. So my little trip to Iceland had a big impact on that issue of the magazine.
So that was so great, and your presentation. I mean, the images were just, as you can see, breathtaking. Still on astronomy tourism, but I'm going to be moving into a bit of a different theme. But as so many of us were really all of North America and beyond was just absolutely starstruck for the 2017 solar eclipse that ran across North America, and our members were no different. Many of them went down to the United States to view it. And we also held a public outreach event at Maffeo Sutton Park, which is our central park that we do most of our outreach in normally. Yeah, Bill got us 400 eclipse glasses from the Dunlop Observatory, and they were gone in minutes, as you probably all experienced too. But in order to sort of kind of capture that whole experience, both the travelers and the outreach folks in Nanaimo, we decided to have a panel presentation at our next monthly meeting. Rather than having individuals present one-off, we really wanted to gather, again, with that sort of collaboration idea, people in a group to pull out themes about the eclipse, similar experiences, compare and contrast kind of thing, and really sort of exemplify the universal experience that it really was for us and for everyone else that saw it. So I'm going to go back now, just heading to the end of the presentation, to astronomy tourism, and I'm going to call AstroFest local tourism. I mean, people came from the North Island, from the South Island, from the Central Island, and yeah, we became a destination. It was pretty cool. And there's been Dorman, the president of the Friends of the DAO, presenting at the City of Nanaimo podium in our venue, and he's got that little fluffy thing. I can never remember what they're called. Space creatures.
Celestial buddies.
What are they called?
Celestial buddies.
Thank you, Aaron. Celestial buddies. Obviously, I don't have children. So just still on the astronomy tourism theme, another person who contributed to our AstroFest success was Dennis Crabtree. Then he came down as a Friends of the DAO person, I believe, or possibly also from his Hertzberg role. But he brought this 3D Oculus Rift viewer, and participants at AstroFest could tour the International Space Station in 3D, which was amazing. And I guess the final kind of tourism I'm going to use mention on this slide is the Nanaimo Astronomy Society has a small collection of meteorites. And so you could think of, when you looked at the meteorite collection, that you could tour the asteroids, the moon, and Mars that the meteorites came from. So this is the second to last slide. And a lot of you will recognize Laurie Roche, FDAO board member and RASC member and RASC Canada executive member, and you name it. Laurie is the astronomy enthusiast role model extraordinaire. Oh my word. So how can we capture what she's having? So this presentation highlighted astronomy enthusiasts, and we want to acknowledge those who carry their passion further by volunteering in astronomy groups like the FDAO to share their enthusiasm and knowledge with others. Through this public FDAO presentation tonight, we hope the collaboration, also highlighted here, contributes to the public understanding of science. Finally, how do you participate? Well, there's a number of ways, but here are three. If you like what you saw, you can attend a NAS meeting via Zoom. Our next presentation is Thursday, September 23rd, and the topic is Why Science Communication Matters with Matt Williams. Very much complementary to this presentation. Matt will talk about not only his nonfiction reporting, but also his science fiction and his interest in human habitation and other worlds. So to get that Zoom meeting invitation, please email info@nanaimoastronomy.com, and we will send you that guest invitation. A couple of other ways you could join our society. Our dues are at half price now, $15 for a membership for a year due to the pandemic, and or join our public Facebook group. Just Google Nanaimo Astronomy for either. And finally, you heard it here first, we are considering offering AstroFest in March 2022 in person, but of course that very much depends on public health guidelines. So I will stop sharing my screen, and we'd love to entertain any thoughts that people have after seeing our presentation.
Thank you both so much. It's fantastic to hear what the Nanaimo group is getting up to. I already have some ideas that I'd like to see us do down here in Victoria as well. I do have a question to start us off. You mentioned the Dark Sky Park, or the Star Park, that you're setting up in Nanaimo. We have a Cattle Point here in Victoria, which is
Right.
pretty good for observation. But I'm wondering if there are any like facilities or anything you've set up there that might translate well.
Not yet. I mean, this is all in the planning stage. At the moment, it's probably more going the other way, where we've been kind of cribbing off what you've done down at Cattle Point and using it as an example for some of our city councilors to say, you know, this would be the kind of signage we're talking about. One of the big things we came up against is that the land that they've acquired is sort of a very large grassy field. It does flood mildly, like in the winter time or something like that, but it's a little bit of an ecologically sensitive area. So there was a lot of pushback on putting anything in like concrete pads and things like that. So we have to do a very, very low impact, ecologically sensitive, you know, any sort of changes to it in that way. So that's been a little bit of a stumbling block. But you know, we had a public open house where the mayor and a whole bunch of city councilors and everything came, and there was super positive feedback from the general public. So I'm very optimistic that it's going to go ahead, and that'll be just as I said, just a wonderful legacy for the city, and just to allow like a family or something to wander out there sometime when there's, you know, a meteor shower or a lunar eclipse or something like that.
Yeah, that's fantastic.
Tony, I just noticed in the chat that Ella and Don were asking where did you say the Star Park in Nanaimo is? So I did put East Wellington. I'll get a link. So, but it's not, just to be clear, it's really, do you want to describe what it is right now? It's not a park yet.
It's a big open field. I mean, I guess it was perhaps farmland or something at one time, and they were able to acquire that parcel. The good thing is, though, unlike it seems everything in Nanaimo has a mountain like right in the south. I don't know what it is for all the parks, and this place is great because it's open. It has a good southern view. So yeah, it is on East Wellington Road, not too far away from the VIU Payne Horticultural Center. Yeah, sort of in that general neck of the woods in Nanaimo. But you'll see a sign directly on East Wellington Road that mentions that it has been acquired as parkland, and it's close. I think another year or two, and I think there'll be something there for us. That's
fantastic. I'll have to come visit in a bit. Yeah, and if you can find the link for that, or want to post any other links for folks to get to the astronomy, Nanaimo Astronomy Society, we'll in the Zoom chat, they'll go to our members, and then we'll get Calvin to repost them over to the YouTube page as well, so people can click directly on them.
Can I ask a question for Tony?
Sure.
Tony, you had, when you displayed it for the Urban Star Park, you had the RASC logo. So are you going through the RASC in order to have the Urban Star Park incorporated as such?
That is definitely what we would love to do. We've been in discussions with the RSC and the people that are responsible for that. I guess the issue is that because we don't have complete control over that piece of property, and there are very strict guidelines about light shielding and things like that, it might be the case that we don't meet those kind of gold standard criteria, in which case we're going to have to back down to something a little less rigorous. But the plan is that we would be at that level of certification through an RESC designation. That's our ideal. But again, we're not calling the shots when it comes to the park. So
yeah,
hopefully
it's a tricky,
it all comes together.
It's a tricky kind of balance between what the RESC is asking for in order to make it legally that, and then what you can actually do. Yeah, so.
Exactly, realistically. But yeah, if we can, we're going to go that way. If we can, we're definitely going to do
Excellent. I look forward to seeing it, and hopefully I'll be able to come out and join you all for the March AstroFest.
Yeah, fingers crossed that we get to meet in person again. Yeah.
Yeah. All right. I'm not seeing any other questions on the Zoom chat. Calvin, do we have anything from YouTube?
Nope, no questions.
All right. Well, with that, thank you both very much for giving us an update on Nanaimo. And if there are any questions about the Astronomy Society that pop up, we'll maybe bring you in for the Ask an Astronomer segment to answer those as well.
Sure.
Yeah, thanks for this opportunity. It was really cool.
Yeah, much appreciated. Looking forward to the rest of the presentation tonight.
Yes, and with that, let me introduce our next speaker. So next up, we have Margie Welchframe, who's been an active RASC member for 4 years. As the second vice president of the Victoria chapter, she's responsible for organizing the information table at the DAO Saturday night star parties. She's a former teacher of 31 years and has taught elementary grades 1 through 6, deaf and hard of hearing students, and language delayed children. She loves to research whatever sparks her interest, and she loves language learning, acrylic painting, the outdoors, supporting women and girls in our world, staying fit, sky watching from her southwest window, and volunteering. Welcome, Margie.
Thank you very much. I will share my screen.
Excellent.
And I'm going to put it on play so it's larger, and you can just tell me if that works all right.
Okay.
Is that okay?
I'm not seeing anything yet.
Oh. All right. Okay, I'll do this again. Share screen. Share.
There we are.
We're okay?
Yes.
And then I'll put it on play. And that's okay.
Yes, it's full screen for us.
All right. Okay. Good evening. This is a wee brief presentation of women in astronomy. Why wee and brief? That's because this presentation starts at 500 before Common Era and ends at 1900 Common Era. What happened between 1900 and now? A lot. And thus would need another few hours in order to cover that part of women in astronomy. So here we go. I need to just take people out here. So just a second, I have to escape for a moment. Take people out and then put play back in. There, now I can see my screen. From 1200 before Common Era to 800 before Common Era, the number of women recognized in astronomy as innovators was very small. This was due to social pressures, lack of opportunities, and lack of systematic scientific education. The first female astronomer seems to have been Theano, 520 BCE, supposed wife of Pythagoras, his student and collaborator. A philosopher, she wrote about cosmology and about the construction of the universe. In 335 BCE, Aristotle's Lyceum of cooperative research and systematic collection of philosophical works was forbidden to women. This attitude, later adopted by the Christian Church, negatively affected the social environment for women. I'm just going to ask if you can see the title of the person above the photograph or not. Can you see that, Calvin?
Yep, we can see it. It looks good.
Okay, I can't see it on my screen. In the 300s CE in Alexandria, the best known woman scientist was Hypatia, who developed tables for the movements of heavenly bodies and developed an astrolabe to measure star, planet, and sun positions. She was killed for her philosophical beliefs. From 476 to 1473 CE, the church was responsible for education. The first universities educated monks and priests. Thus, convents and abbeys benefited. Hildegard von Bingen in 1136 CE was a German Benedictine abbess. A polymath, she had visions and wrote about the human as microcosm and the universe as macrocosm. In the 16 to 1700 Common Era post-Renaissance, the microscope and telescope were invented, but universities were still not open to women. Women could work on astronomy only as a hobby. In 1600 CE, Sophie Bra was a noblewoman with knowledge of astronomy, chemistry, and medicine. She worked alongside her brother, Tycho Brahe. Her observations helped to establish the elliptic orbits of planets, which Johannes Kepler later used. Other women were now assisting their brothers and fathers in astronomical pursuits. In France in the 1700s, women began to work at the Paris Observatory, predicting the exact return date of Halley's Comet and calculating eclipse dates. Carolina Herschel in 1750 CE was the first salaried female in the history of astronomy. 50 pounds a year she earned. She worked in partnership with her brother Wilhelm, recording his observations, including 2,500 new nebulae and star clusters, which eventually became the New General Catalog. In 1786, Carolina was the first woman to discover a comet. Later, in 1828, she was the first woman to be awarded a gold medal by the Royal Astronomical Society. In the 1800s, Mary Fairfax Somerville undertook what today we call astrophysics. Described as a mathematician of the very first rank, she wrote a standalone exposition of the mathematics behind the workings of the solar system. Her book, On the Connection of the Physical Sciences, was its publisher's most successful science book until Charles Darwin's The Origin of Species in 1859. This was the period of the sciences becoming places for women. In the mid-1800s, Maria Mitchell was the first female American astronomer. She was the first person to discover a telescopic comet. In 1865, she was the director of the observatory at Vassar Female College, New York, and the first female professor of astronomy. She studied comets, nebulae, solar eclipses, double stars, and the satellites of Saturn and Jupiter. In the early 1900s, Harvard College Observatory created opportunities for women astronomers. Astronomer E.C. Pickering had been working with 80 women whom he called his computers, who cataloged and interpreted astronomical data. One of these women, Williamina Fleming, helped to develop a common designation system for stars and cataloged thousands of stars and other astronomical phenomena. Among several career achievements that advanced astronomy, Fleming is noted for her discovery of the Horsehead Nebula in 1888. 8 years later, in 1896, another of Pickering's women, Annie Jump Cannon, classified stars according to their temperatures. Her spectral classifications became universally adopted. She eventually obtained and classified spectra for more than 225,000 stars. Her work exerted a major influence on the evolution of the science of astronomy, from one of mere observation to one of great theoretical and philosophical content. Female computer Henrietta Swan Leavitt, hired in 1902, was tasked with examining photographic plates in order to measure and catalog the brightness of stars. Her work provided astronomers with the first standard candle with which to measure the distance to faraway galaxies. She was responsible for measurements which were key to the concept of the expansion of the universe, the theoretical base for the concept of the Big Bang. Now, finally, women astronomers in North America and in Western Europe obtained the possibility of doing meaningful work in their chosen field of astronomy. Today, approximately 30% of astronomers are women, one of whom, Andrea Ghez, received the 2020 Nobel Prize in Physics for the discovery of a black hole. And now for some Canadian women astronomers. Allie Vilbert, I'll try that again. Allie Vibert Douglas, Miriam Berland, Helen Sawyer Hogg, Isabel Williamson, Mary Gray, Mary Lou Whitehorn, Laurie Rousseau Neptune, Victoria Caspi, Wendy Freeman, Sarah Seeger, Jocelyn Reed, Tanya Harrison, Michelle Kunamoto, Natalie Willett, and Kim Venn. We have come to the end of this look at women astronomers, but it's only the beginning of the lives of many more fabulous women in the pursuit of their astronomical passions.
Thank you so much, Margie. Definitely some names I was familiar with, but I learned quite a few there as well. I'm always interested to learn more about women in astronomy and science. So many of these stories are overlooked, and so many of them are so powerful as well. Let's see, do we have any questions in the YouTube chat? I'm not seeing any in the Zoom chat.
None in YouTube.
None in YouTube? All right. Yeah, and I
want to ask a question. Sorry.
All right, go ahead, Laurie.
Margie, I don't know anything really about, is it Hypatia? Is that how you pronounced her name?
Hypatia, yes.
Yeah, can you tell me a little bit more about her? Because I don't really know very much about that.
There is very little known about her. Actually, what I said is almost all there is known about her. She is the supposed wife of Pythagoras, but even that is not known for sure because there is a record of him having a different wife. So she's very little known. There is probably more information deep down in some records in some location, but we'll have to find it.
If I could mention, there is a film about her. It's called Agora, and I watched it a while ago, but I want to watch it again after you bringing her up. I mean, you know, I'm just looking at Wikipedia, 2009 Spanish English language historical drama. So, you know, you'd have to take it in that context, but it does, you know, highlight some of the key parts of her life. Agora, A-G-O-R-A. And I just absolutely loved that historical sweep, Margie. That was fantastic.
Great. I was saying that Hypatia was the supposed wife of Pythagoras, but that's not right. That's Theano.
Yeah.
So there's very little known about her either. Hypatia, I don't know how long she lasted. She had wonderful, interesting philosophical beliefs, but they were not popular. So She was
Right,
gone.
she was killed. Yeah.
This is Dennis Crabtree. A very interesting talk, Margie. I learned a lot about the BCE female astronomers. There's a few more Canadian astronomers from the recent, well, somewhat recent past. Anne Underhill, very well known Canadian astronomer, born in Vancouver, worked at the DAO for several years. Jean McDonald, another woman astronomer that worked at the DAO. And in fact, when you look at the staff of the DAO in the 1950s, 25% of the staff was women. So, you know, that's higher than what most universities have today. So it was really quite an achievement, or maybe it was just a quirk. I don't know, but it says a lot. Just another note about Helen Sawyer Hogg. I forget where I learned this. Anyways, you know, when she worked at the DAO, she wasn't paid, and her husband was offered a position in Toronto, but they really had a hard time deciding whether to stay in Victoria or go to Toronto because she was so well treated in Victoria. They liked her life in Victoria. They liked working at the DAO. So, you know, it's just, again, I think it's the challenges that female astronomers face is they're attached sometimes to a male astronomer. You know, it's just their life is much more complicated. So, but Canada has a great history of women in astronomy, and a lot of them are associated with Victoria. So, yeah.
Apparently, Helen Sawyer Hogg wrote astronomy columns for the Toronto Star.
Oh, she did for many years. Her husband, Frank Hogg, wrote those. And when he died at a very young age, Helen picked them up and continued. And I think she did a better job than he did and was a very, very popular promoter of astronomy in the public. And yeah. So.
If I could just interject, just following Dennis's comments, there's a wonderful radio interview with Anne Underhill and Jean McDonald from 1955 at the DAO. And I'll put it in the chat here. And I believe it's Anne Underhill that says that there were no barriers in Canada at the time to women using large telescopes, unlike other countries. And so that's one of the things that she found, which is actually quite amazing for the time, really. So I'll stick that in the chat now. So
well, thanks, Don.
We had one of the HAA women astronomers who was quite young, who had a very young family, come and talk to a class, a grade 10 class of women, of girls that came one day. And one of the kids said, like, you know, did you ever have any discrimination? Did you feel as though it was hard for you to get a job? And she said that not before she had a child. That when she was just a single person, or just, you know, married without children, that her life kind of went along as she had planned and everything was fine. And that as soon as there were children in the mix, then it became harder. And that she had a little bit more difficulty in keeping up with everything and getting the time off that she needed, or, you know, I mean, anything like that. And so she was very I guess truthful with the girls, you know, about what she had. And she said it was more difficult for women with families to continue their work. So it would be interesting to know whether that's a continuation. That was from a couple of years ago. So,
of course, Helen Sawyer Hogg was very well supported by men in her life. There's this great. A woman did a PhD thesis on Helen Sawyer Hogg, and in terms of the communication of science. And she has a great bio. The first chapter of the thesis is her bio, but she was well supported by her thesis supervisor at Harvard. Of course, Frank, her husband, looked after their baby while Helen was observing, even, you know, and we know probably everybody's their death story by now, but also John Stanley Plaskett found money, even though he couldn't pay her, he found money to give her that allowed her to hire, someone to look after their house and the baby while she was working. So, yeah, I mean, people, they need support, and Helen was very fortunate that she had that support.
Mhm. We do have one question from the YouTube chat from Rigel Garmin. Love that name, by the way. Let's see. It's a little back here. Is Annie Jump Cannon the astronomer who came up with the OBAFGKM spectral classes?
Well, maybe David Lee would like to answer that.
I believe that is the case.
I think it is, actually. I
Yeah,
have to confirm that, though.
yeah. I believe you mentioned. I'm blanking on the name now. One of the other computers created the alphabetic classification of them, and it was Annie Jump Cannon who recognized that they could be organized in groups by temperature. So the OBAFGKM were the alphabetic classes that they had already been sorted into, I think based on the strength of the hydrogen alpha line. And then Annie Jump Cannon rearranged those letters into that system.
Oh, be a fine girl. Da 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 da. Yes.
Well, there's been different versions of that now, I guess. I mean,
Annie Jump Cannon was very good friends with the Plasketts, and when John Stanley Plaskett, Reba's son, Harry Hemley, went for First World War, she knit him a sweater and sent it to him over in France.
Lovely. Well, it sounds like we've got a lot of knowledge in the group for some more recent Canadian astronomers. We might have to put together a talk on that in the near future. All right. Well, thank you again very much, Margie.
Most welcome.
Yeah, we look forward to hearing from you again. And I think at this point, we'll turn things over to our Ask an Astronomer group. So if you haven't already, if you have any questions about astronomy, science in general, that you'd like to ask our panel, we'd love to see them in the YouTube chat or the Zoom chat. And I think I'll turn things over to, I believe Amy's hosting.
Yeah, I'm here.
Excellent. And we have Dan Posey and Ruhi John Mohammed as our panel this evening.
Hi, welcome. Dan and Ruhi, would you like to both just give a brief, at this point, if people have been to other star parties, they've seen you both before, but some people are new. So would you like to just give a brief synopsis of who you are?
Please go ahead, Ruhi.
Okay, for sure. Hi, my name is Janeane Mohammed. I'm in my final year of my degree at UVic, doing my combined degree in astronomy and physics. I do research in exoplanets around white dwarf stars, as well as outflows from deeply embedded protostars. And I also help run the telescope up at UVic on Wednesday nights for our open houses.
Yeah.
So I'm not an astronomer per se, but I have been involved with the amateur astronomy community in Victoria for the better part of the last decade. My background is history of astronomy. So that's my area of specialization, but I'm also a Plaskett telescope operator on Saturday nights during the summer, and you've probably at this point seen me around, so I don't know that much more introduction is necessary.
Okay, so as Aaron mentioned, if you come up with a question as we go through this section, just throw it in the chat in YouTube or into the Zoom chat, and we'll grab that. And I know we've got people here from as far away as Arizona and Saskatoon, so I'm sure there's lots of questions. But to start things out, and I don't know, maybe both of you would have an answer to this, but can you suggest some locations or some more locations kind of south of Campbell River for decent viewing for amateur astronomers?
Yeah, there are lots. So one of the tricks has already been mentioned earlier this evening, which is that if you're trying to go south, you really want to avoid a mountain getting in your way. The trouble with that is that there are a lot of mountains on the island that seem to line up perfectly to get in the way of what you're trying to accomplish. So a few tricks. One of them, whatever you're doing, you want to make sure that there isn't a big population center right below you, unless you're trying to get a shot that's going to use filters that allow you to get past light pollution. So if you can figure out a way of just getting a little bit in toward the spine of Vancouver Island, you tend to be able to find a way to just move off those coastal cities. So you move away from Nanaimo, Chemainus, Ladysmith, everything else in between. Just going a little bit west helps. The trouble is you don't want to go too far west because then you're right into that cloud band that never seems to go away. The other one is I mentioned hills and how they like to get in your way. That honestly, the real trick is just get on top of the mountain and then you're okay. It's not a complex recipe, but the darker the skies, the better your results will be, whether you're doing visual or astronomy or astrophotography. And then on the other side of it, if you can get that perspective by going up on one of those hilltops, there may be, depending on what's available in your area, either public access, or you might have to do a little bit of walking. There could be a park. So just bear in mind what's trespassing and what isn't, and what's crown land and what isn't, and then you'll be okay. But that's kind of the generic rule of thumb that I have. I've found quite a few spots along the way. I admittedly do most of my observing these days down south in Victoria, but as long as you don't have the Victoria light dome sitting on top of your target, or if you're north of Nanaimo, the Nanaimo light dome sitting on top of your target, you'll usually be okay.
I know the question, there is a question that's come up just about the West Coast, but I imagine, and I've noticed that the West Coast is a lot like the North Island. There's a lot of dark sky, in my opinion, but I'm very amateur. So is that kind of your experience, Dan and Ruhi?
So yeah, Ruhi, I won't jump in again if you want to recount your.
I sadly, I'd love observational astronomy, but I really do not get out enough to do as much stargazing as I should. But like the places that I find the best, at least in Victoria and driving distance, are Cattle Point and the top of the Malahat. Especially at off-peak times, there's not a lot of people going there. You get a lot of your own room. It's really dark. It's cold. But those are like some of the only places in Victoria that I know off of my heart that I know are well. They're good.
Yeah, so that's
actually, sorry. Another thing to note is try to avoid extra things like the moon. I mean, that's going to help. Like, even though there's light pollution, all the other additive problems associated with viewing, get rid of those too. So head for moonless nights.
Yeah, full moon's about as bad as being downtown Victoria in terms of context. So a couple other final points. West Coast, it's amazing if you can get out there and it's clear night. It will be darker than anything you can find pretty much anywhere else on the island. The challenge with it is that the weather behaves very differently and you're often socked in with marine air. So if you get a clear night, then it's going to be one of those things that you might remember for a very long time, but the odds are always a little bit dicey. So I can count on one hand the number of nights I've driven out on the West Coast and had one of those perfect nights. I can count on more than one hand the number of times I've driven 4 hours and come up with nothing because the weather just doesn't cooperate regardless of what the forecasts are saying. The other thing, and this goes for anything, plan some kind of coffee stop on the way out, and if you can on the way back, because you will be tired, and the farther out you go for dark skies, the more sleepy you'll get behind the wheel. And on the way back, you'll just want to warm up, and you won't care if it keeps you up the rest of the night.
Can I add a reflection? I'm not an observer, but when you said that you'd have a memorable night, Dan, and Ruhi, you said you go to the top of the Malahat. When I went to the International Year of Astronomy Star Party, co-hosted by Rask Victoria and the Cowichan Valley Starfinders, it was at the Victoria Fish and Game Club on Malahat. And I remember Gary Saronic, the writer who is also presenting, saying it was the first time he'd ever presented to the sound of gunshots.
Oh my God. Yeah, that's a memorable night for sure.
And I guess that's just another comment on how tired you get. Sometimes it takes the music of gunshots to get you out of bed in the morning after a good night of observing.
All right. Question from YouTube, which is, if you could travel to the Andromeda Galaxy, or at least travel outside of the Milky Way, would either of them look anything at all like we see in the photos, or is it just too dim?
Okay. I might need a little help on this one, but I feel like as you get closer to the Andromeda Galaxy, you're just gonna be seeing a lot more as you get closer, and the core of the galaxy itself is considerably bright. That is mostly what you are seeing in these pictures because it washes out the rest of the galaxy. So as you leave ours and go into interstellar space, you're going to be seeing more of the galaxy itself because the core won't be washing out everything. And yeah, Aaron, jump in if you'd like. I'd love that.
So I think that there's a couple ones on this. One is that as you get closer and closer, you're going to have the angular size of that galaxy change, which means it's going to spread out across the sky. So for some context, even the Milky Way is monstrously bright, despite most of it being blocked out by dust. So we're not seeing most of the light in the Milky Way. But if you go out to a real dark sky site, one of those places I mentioned that's really truly dark, it's enough that it can cast a shadow, where you can see the shadow or read a map or something if you need to off the light of the Milky Way alone. Nothing else coming off of it. And that's with most of it being blocked out by gas and dust. So if you were to try and go out to one of these distant galaxies, what would likely happen is that you would see it get increasingly bright until you were into the middle of it. And then at that point, depending on where you are, a lot of that light would start to disappear because of all the other material and the way that just wouldn't be letting it all transfer through. So the bird's eye view coming from the top, you'll see the most. But galaxies are kind of like a dinner plate. They're these very thin, disparate bodies. And so it all depends on the angle you're looking at for what you would actually see if you were to get in your magical spaceship and get there.
Yeah, I think galaxies would probably be the only like large, when I say large, I mean like light year or larger scale object that would actually look better as you got closer. I'm just reminded of a quote from Carl Sagan, like not a sunrise, but a galaxy rise. If you were on a planet that was like out in the halo of the Milky Way that went up over the top of it, yeah, you would be able to see the full sort of extent with the arms and stuff. Like Andromeda is 2.5 million light years away, and you can see it naked eye. You can see the core naked eye. So its light is packed enough together, like the stuff emitting is packed close enough together that if you could get close enough that it filled up like 30 or 40 degrees of vision, it would just look spectacular. But yeah, the concern about getting closer and it not looking as good is definitely true for things like nebulae, where you're getting very dim light from a very diffuse gas. And so as you got closer to it, it would look dimmer because that diffuse light is getting spread out over a larger area. So like if you tried to go to the Eagle Nebula, like the Pillars of Creation, like you probably would just see a couple bright stars, maybe some wisps of gas, and then like some dark nebulae that blocked light from stars behind, but you wouldn't really see much light coming from the gas around you, just because it's so spread out. You really need that far perspective to sort of narrow down that field of vision, so you're collecting light over a much smaller angular size. That's why like those backyard telescopes that you can get at like Walmart that advertise like 300 times magnification aren't great, because you're just spreading all that light back out again. And so even if you get really good magnification on a nebula or something, you often just end up washing it out.
Thank you. I'm not sure who's best to answer this question, so I'll throw it out there. So what gases are needed to create a star?
Yeah, so stars are primarily made of hydrogen in the first, like the first most amount of gas is hydrogen, and then your second would be helium. So those are what stars are made out of. And then as fusion occurs in the center of your stars, you'll start making heavier and heavier elements, or what astronomers like to call metals. Anything that isn't hydrogen or helium is a metal. So you'll get, and then when stars actually end up exploding, you'll end up getting things like oxygen or heavier things up to iron, which then a star cannot fuse anymore in its core and will then die. So yeah, but for a star to actually keep itself alive, you'll need hydrogen first, and then it'll start going into helium fusion.
Yes, and the classification of anything heavier than metals, basically having a 3-item periodic table, is one of the reasons why I gravitated to astronomy as an area of interest and passion, because even I can remember that.
Yeah, very, very simple, eh? Very simple chemistry to remember.
So once we've got the right gases, how long would it take for a new star to be seen? Like, how long would it take for a star to form?
A very long time. I do not have a number off the top of my head, but when protostars are forming, it can take, definitely maybe like a million years, more than a million years for fusion to actually start in the core of the star. Because once fusion starts, then the gas and everything around it, the things that are making the planets, the thing that's feeding the star itself and helping it grow, will all get dispersed out into space due to stellar winds. So usually it's usually at least a couple million years, I think. Someone please correct me. I don't know it off the top of my head.
Yeah, that's about what I remember as well. It takes quite a bit of time, and it's a bit of a delicate balance because you have all the matter falling in from the surrounding nebular cloud. So you have to accumulate enough mass to hit the minimum thresholds for fusion, because as gravity pulls it in, it's going to then heat up. Eventually, you'll get enough crush of gravity that the core is going to light up, and you'll get fusion. But you have to actually hit the thresholds to be able to do it. Otherwise, you result with failed stars like brown dwarfs. So quite a bit of time, because otherwise you wouldn't see anything like the pistol star or anything else, or anything in that 50 plus stellar mass range.
So have we, in the time that there has been recorded viewing, have humans seen where there wasn't a star and then there was a star? Is there an example of that?
We've definitely seen protostars, baby stars, but I'm not sure.
Yeah, I know that we've observed the process, but the challenge is that for a lot of the things that would take that kind of delicate measurement, we've only had about 500 years to do it.
Right.
Yeah, for sure.
And,
like
and that's being generous.
Yeah.
Like we've been able to look at different stars in different stages and then be able to piece together some sort of cycle that we know that stars can go through before they start fusing. But I don't think we've been able to pinpoint when a star was just being born and then watch it. That's a long time.
Yeah. A good analogy for that is like thinking about being an ant with a very short lifespan of like a couple weeks, and trying to figure out like the life cycle of a human by just taking pictures of humans during your lifetime. So like you can take pictures of babies, you can take pictures of kids and adults. You can sort of piece them together in a timeline, but you're never seeing one person like go from baby to like teenager.
And a lot of the background for this has been evolving largely as part of 20th century and now 21st century science, where prior to, I think it was 1929 or 1930, we didn't even know that stars were made of hydrogen. There were competing theories between uranium, which was a new hot kid on the block, and if you go back just 20 more years, there were competing theories on whether it was a pile of burning wood or coal, because of course, as coal took over, it became much more interesting to have the sun be a pile of burning coal. Those weren't fully taken seriously, but it gives an idea of how far things have progressed once the instrumentation and in particular the observational and theoretical basis were able to catch up with it in the last 100 years.
Thank you. Maybe this one's easier. Are galaxies stationary? I guess this kind of goes along with that, the earlier question.
No, they are absolutely moving through space at gigantic speeds, not only forward, but they also do have angular momentum and are spinning. Hence why everything in the galaxy, stars, your black holes, gas, everything is spinning within the galaxy, and they are moving. So our galaxy or our universe is expanding, therefore the space between our galaxies is getting bigger. So our galaxies are moving in space towards each other and away from each other, and then also in a disk.
So does it look like it's stationary to us because we are also moving?
Yes, exactly. It's hard to see something that's moving when it's so far away. Yeah. And we're only looking at it for such a short period of time as well.
So this one's kind of cool on two levels, because one of the big contributions that astronomers at the DAO made in the 1920s and 30s was mapping out the rotation of the Milky Way, where they confirmed a bunch of observations and theories made by Lindblad and Oort out of Leiden, and I can't remember where Lindblad was based. But so they were able to make these very fine measurements that required spectroscopic analysis to be able to even determine that those stars had a velocity that would be distinguishable to give an indication that they're moving. And so even with our own galaxy, which is as close as we can get, it's very difficult to see this rotation. I'm blanking on the astronomer's name down at Mount Wilson, but he used a blink machine trying to map out rotation in the triangulum throughout the 1920s and kept on thinking that he was able to see the triangulum rotating, which led to a lot of strife going into the Great Debate in 21. And again, triangulum is part of our local group, so it's this local grouping of galaxies that our own galaxy orbits with. And even that is too far away to see it. It's such a long scale. I think for our galaxy, it's 240 million years for one rotation. So you're just not going to be able to measure it easily without very sophisticated instrumentation. And so you probably won't see it in our lifetime. And again, that's as close as it gets. So the farther out you go, the more difficult it is to see it.
So, thank you. Dan, I feel like this question's going to be for you, or Dennis, if he's still on. How many female astronomers have worked at the DAO? And what year did the first female astronomer start there?
I might actually have to toss this one over the fence to Dennis, but it's a tricky one because it depends on whether or not Helen Sawyer-Hogg is considered to be a staff astronomer. I mean, she was certainly incredibly influential on the institution once she joined, but it was an odd arrangement where Frank Hogg was considered the staff member, even though Helen outpublished him during the entire period that they were together in Victoria. And it was anyway. I'm mean to Frank. I don't try to be, but she was the superstar of women in early Canadian science, much less just looking at astrophysics and astronomy. So I know that there's that, but I peter out a bit after 41. So this is where Dennis could come in if he's still on with much more knowledge of the institution after that point.
Yeah, Dennis, I think, has left the building.
Yeah, there's a great cast of characters. It's just one that I don't have on the top off the tip of my tongue. I think that the proportion has continued to be overrepresentative compared to other institutions, which is one of those positives of that early institutional culture that came out in Victoria. But that will have to be one that we could rain check for another week.
Okay. And then another question, and Ruhi, you might know the answer to this, or Margie might know the answer, which is essentially, with female astronomers, does it happen that males are getting credit for work or discoveries by females? Does that still happen? It has in the past, I guess, but does it still?
Oh yeah, it was very common in the past for females to not get the recognition that they deserved when they found it first. I haven't done a lot of publishing yet. I'm still in my undergrad. But at least I know now it's definitely getting better. Women are getting the credit that they deserve because they are getting higher positions, at least in universities and in corporations, regarding physics and astronomy. I'm sure it still happens though. I'm like definitely positive. There's a lot of work that we need to do to be getting better. And yeah, we have gotten better, but there's definitely still work to be done. For sure, not even just in women getting the recognition that they deserve, but also even in just their research being treated as equal to their male counterparts. Women do have to work considerably harder to be seen as a real scientist or a real astronomer than men. So yeah, we still got some work to do, but I think it definitely still happens.
Obviously you're optimistic because you're in the space. Like that's
yeah. We're getting there.
Didn't Jocelyn Bell, who was the person who found the pulsar, like did the work? I mean, she was the one who found it, and then her supervisor got the Nobel Prize, and she got nothing. You know,
when
so
was that? Like, what year would that have been?
56, I think, 55.
Yeah,
there.
yeah. I mean, mind you, Jocelyn is still like right in there and doing all kinds of really cool stuff. But I mean, she should have been one of the people on that Nobel Prize. Yeah. So
sad.
Thank you. Barring any other questions, which I'm not seeing right now, I'm going to ask, I'll start with you, Ruhi. Can you say just a little bit about why you've chosen this field and kind of what your journey to get to where you have been is?
Oh, yeah. I was the kid who always wanted to be an astronaut. I was obsessed with space. That's all I wanted to do. But I definitely always wanted to go into astronomy. And then high school happened, and then I realized there was a lot of math. And I was not very good at math in high school. And I had the teacher tell me that I should not be going into astronomy. I should not be going into physics. I wouldn't be able to do any of it. And I was like, I'm going to show you. I'm just going to get the degree. I'm going to rub it in your face. But then I fell in love with it. First year in my degree was, your basic physics, but we had, I had my astronomy class 150 with Sarah Allison, and she was like the first female astronomer I'd ever met in my life. I had met only men up at that point. And she blew me away. She would just like, her and her research were just absolutely spectacular. She's also such a nice person that I like couldn't help but just stay in her class, and she was really helpful and really nice when I needed help. And honestly, just the astronomy department at UVic has just been absolutely amazing. There obviously were a couple people where, we had some trouble, but most of the time it was just people who really wanted to help you, no matter if you were a guy or a girl, or if you were LGBTQ+, no matter what. Like, the department here has been just so nice and so helpful and respectful, that, this degree is hard. There's been some tough times, but they really help you pull through it. And so, yeah, I'm thankful that I came here, because I applied here, Calgary, and Saskatchewan. But I was like, I like the island. I want to see what it's like to not be in the dead of winter in Calgary. But I don't know. I'm very thankful that I ended up here in Victoria, especially with the DAO here. Everyone here has just been so helpful and kind. And there have been so many opportunities that I found being here, even as a woman in astronomy. that I can't help but be thankful. So yeah, I'm glad I chose astronomy and stuck with it.
Awesome. Thank you. And Dan,
I've got can I do a follow-up to that, Amy?
Oh, yeah. Oh,
yeah, it's Janeane, yeah. Just for both Ruhi and Dan, how did you get the confidence to do the Ask an Astronomer role? It seems pretty responsible, and particularly from your different backgrounds, I was curious about how you came to be, because I've seen you, Ruhi, on the Astronomy Open House at UVic, and you've been rocking it for a while there. I haven't seen Dan in this role, so that's cool, because Dan presented to us up at VIU, of course, or at NAS, of course. But you've got you're coming at it two different ways. So what's up?
Dan,
I got told I was doing this.
You were asked. I asked.
On a more seriously though, I've kind of done this ad hoc as a telescope operator for the last I think it's 8 years now. I always would open up the control room so people could come in, and that entire process was a lot of this, which is pitching answers to questions, getting stumped. Luckily enough, my background being in outreach and tourism and boosterism and all that at the DAO and scientific education within that in the 1920s and 30s, I realized that a lot of those astronomers got stumped too. So you just take the knocks as they come along and have fun and hope that the questions aren't too hard, I guess.
Yeah.
And then if they are, toss them over the fence to Ruhi.
Hey.
Thanks. That's great to have that perspective, because I mean, one of the things that I've always been not comfortable with in public outreach and the very few things I've done is exactly that, is getting stumped. So you just guess practice, I guess.
Yeah, like I've been again with Open House since 2018, and when I first got there, we did our Q&As, and then I got sent up to do the DFM tours, and I didn't know much, and I was very scared of being wrong. So it was definitely a learning curve on how to take a question. If I don't know the question, ask someone else, find it up, look it up on Google if I have to, because I am not all knowing, and it took a while for me to truly learn that and be okay with that. But then I just learned to have fun with the questions, and even I get a little nervous before doing Ask an Astronomers or even before any open house. It's just something that comes with the gig for me, at least, and I just got to learn to power through and be okay with being wrong, and that's okay.
And a good example of self-fact-checking is that Jocelyn Bell's discovery was in 1967, not 56 or 57, whatever I said. So
yeah, one of the things I learned about doing this outreach stuff was the first part is getting comfortable with not knowing something, and then taking the next step to maybe not being able to answer their question, but keep a interesting conversation going anyways. That's a skill to learn for sure.
Oh, wow. That's also a really helpful insight. Yeah, there was, I think I saw something through, what's his name? The Californian educator, but it was sort of like, I'm going to say 30 things you should know if you're going to do a public outreach, like kind of the standard questions. But this is different, like Ask an Astronomer is a lot broader, I think. I'm talking about public outreach events, the Saturday star parties, and there's probably 10 or 20 or maybe 25 sort of standard questions that you get a lot of. But anyway, thanks, Dan and Ruhi for that, and also Calvin.
Of course.
Yeah, if I can offer a little bit as well. I've done astronomy outreach since, I guess for 10 years or so, similar to Dan. And yeah, it's as well as keeping the interesting conversation going, not being afraid to be wrong, and then also giving yourself permission to guess sometimes as well, but to be clear about when you're guessing. So like a lot of the times I'll get a question where I don't really know the answer, but I have some knowledge that could help me make an educated guess towards it. So I'll be like, yeah, I don't know that for sure, but given what I know about this and this and this, like this is how I would play that out in my head. And I think modeling that and like that sort of hypothesis generating based on your prior knowledge is an important thing, not only to be able to do, but also to model to people as well. Like modeling using your background knowledge for stuff like that.
That's such a helpful insight, and it also really segues back to our presentation, you know, in Science Communication Matters, and you know, the kind of if you're going to be contributing to the public understanding of science, then how sure do you have to be about all these questions? And I like that idea of modeling a hypothesis. That's really cool.
Yeah, as long as you're clear that this isn't like knowledge, this is your guess. I think it's a really valuable thing to do.
Yeah.
Yeah. So Dan, just knowing that you're not that this is not your field all the time, kind of how did you come to be, you know, the one of the historians, I guess, for the DAO? What is your path to get here, and why did you choose like, why do you love astronomy?
Yeah, it's actually an interesting one. So I came to it more from taking courses in astronomy, but just like every good undergrad seems to go through, there is that crisis of confidence where I had to pick what stream to go down, which was restart a degree and try and go back and switch over to astrophysics or keep on the path I was. And for me, I realized that I probably had a opportunity, if I stuck with the history side of things, to still keep my passion as a passion without trying to turn it into something that I was going to do professionally, but still make a contribution that was meaningful by going that route. And so I get to go out in the evenings or on off nights, or these days off my balcony downtown, and take astrophotographs. And you know, I've had quite a bit of fun with that and had quite a few of them published, but then that still gets to stay fun instead of being a professional piece. And so then coming out and being able to have great conversations like this is as much a hobby as anything else, and it's not tied to work, and so it just gets to stay fun and be really enjoyable. But luckily I did take quite a few pursuits over the years, and through the different things I've done, I've interacted with a lot of astronomers, which means that I've picked things up as I go. So even if I don't necessarily have the math, I probably still at least have the picture of how the things fit together. And certainly on the data acquisition side, I'm much stronger than in other areas.
Awesome. And I'm not gonna let you guys go quite yet. There's one more question that's come in. This is the last one. So this is about the James Webb Telescope, which there's a lot of buzz. I know exactly. I've seen some images lately. This is good. But the question is that it's a very sophisticated machine. So what astronomical questions or theories do you think the launch will answer or solve?
Oh, Lord. Oh, there's so many. It's a good question. At least I can tell you the one that I'm most excited about. I'm very excited for James Webb to tell us more about planet evolution. It's the bigger brother to Hubble. It is going to give us so many more pictures of planets around stars that we couldn't see. So when we're actually looking for planets, we have a huge bias. So we normally find really big, hot Jupiters that are really close to their stars. Or we can find things like super Earths or sub-Neptunes. But like for planets like Mercury's and Venus's and things like that, we're going to need a much bigger telescope to look for them. So hopefully, James Webb will give us more examples of these planets around stars and help us find out how our solar system was made. Like we truly don't have a set answer on how our solar system came to be. We have our theories, of course, but I think James Webb will help us put it in stone a little bit more.
So one of the other cool things about James Webb is that while it overlaps with a lot of the visual spectrum, it's much more shifted into the near infrared as well. And with Hubble, even though we have the deep field, the ultra deep field, and then the extreme deep field, there's a limit on how far you can punch through because of redshift skewing the light of the most distant objects more and more into the infrared the farther out you go. And combined with dust extinction, you tend to get these very hard limits because of the sensitivity of James Webb going out past 1,000 nanometers. I can't remember what it actually goes out to. I think it's like 1,200 or something. We'll be able to see farther out, not just because of its additional light gathering power, but also because of the kind of purpose-built wavelength it's selected for, which will give us the most distant optical images that you can get, just recognizing that what we would consider to be the visual spectrum at those extreme conditions is not really the visual spectrum anymore. And so the first question is the one that Aaron has put into the chat, which is, will it hold together? But then there are so many other ones that are going to come up once it gets out there and starts doing its thing. And yeah, just thinking about what Hubble's given over the last 30 years, it's going to be a really exciting time for this next generation.
Yeah, to build off of that, I'm also really excited for James Webb to tell us more about the first galaxies that were formed after the Big Bang. It will be able to look further back in time, and we'll be able to learn more about galaxies, protoplanetary systems, everything of the sorts. James Webb is really exciting. I'm so happy it's finally at the launch pad. And fingers crossed it will actually launch and get to where it needs to go.
And Ruhi, right now we're at what? Is it 800 million light years? Or pardon me, 800 million years after the Big Bang, approximately,
I think
for the
so.
farthest
That
look back.
sounds about right.
And I think that
sounds
this
about
one's
right.
supposed to buy us all the way out to 200 million years past the Big Bang. So right on the edge of the first star formation, I think it's theoretically within bounds of what it could do.
Mm-hmm. It's going to be really interesting.
The challenge with this one is that because it's at a Lagrangian point, it's not going to be serviceable by a staffed mission. So unlike Hubble, we can't just go up there and swap out a better camera as cameras continue to improve. So I don't know whether the full 30 years is necessarily in scope.
Yeah, we'll see.
Hopefully, fingers crossed.
Well, thank you guys both very much. And as always, the last question goes to David Lee. And David, can you tell us a little something about EAA tonight?
Yes, thanks, Amy. I just wanted to say how much I've been inspired tonight by the talks about community and women in astronomy. So I thought I would start off with something that Margie mentioned. She mentioned Wilhelmina Fleming's discovery of the Horsehead. Now, I understand it was actually credited to somebody else, just like a lot of these things have been, but she is the originator of it. So I'm going to lead just with a picture of the plate and then just a general description of what was in her logbook. So here's the original plate. Let's see if we can find it here. You can actually see the Horsehead right here. And I think I'm trying to find the logbook. Let's see where that is. And here's the logbook right here. And she actually describes it as being a eraser smudge. And I think that's absolutely perfect. You can see it right here. And it's very, very faint. And it does look like, I don't know if I can get a bigger image of it. I don't think so. Anyways, it's just this area here. It's a bit of a smudge. And here's a modern day picture of it. But I think I mentioned this to David Payne, and I think he's getting ready to show us some other images as well, and then lead into his recent photo of the Horsehead. So that's where we're going to start. Dave, are you ready?
Yeah. Am I on?
Not yet. Oh, I can see you, but you have to share your screen.
I'm just wondering if you could hear me.
Yes, we can hear you. Yeah, I think David has a picture from the Palomar, and then he has a recent. You have a picture from Palomar, right?
Yes, it's actually a combined picture.
Okay.
Sorry, it's right here. Yeah, a little bit of a personal story. In the upper right is a picture from the Mount Palomar Observatory taken around 1960. And you can see it in the upper hand corner. And it's interesting because this was taken with at Mount Palomar Observatory, which had the largest telescope in the world for a long period of time. I think it was 200-inch telescope, just a massive thing. And this picture appeared in an atlas I had as a kid that was inspiring to me. I didn't know exactly what it was, but I wanted to find out and read about it. And then I didn't realize at that time that eventually I could actually take a picture of the same thing in my backyard. It's just incredible. So there's about 60 years between Wilhelmina Fleming first noticing that and this picture, and another 60 years-ish between this picture and the one below it that I took, again from my backyard. A lot of this has been due to a lot of the change between 1960 and now has been due to digital cameras and the ability to stack photographs, take pictures in color, as well as computer control of telescopes. Everything used to be done manually, of course. Between Wilhelmina's discovery and this photograph, there were quite a few changes too. We went from glass plates to film, for example. But it's interesting to put it in perspective. Of course, the big telescopes have taken different filters, different wavelengths of light, and you can get any number of pictures showing various details of the nebula now, and it is actually part of a large nebula complex, but it's part of what turns out to be quite a nice vista.
Yes, it's very beautiful. Yeah, I think we've come a long ways from that eraser smudge, though I would imagine at the time, I don't know if she would have understood the significance of it. I mean, she would have seen it and through her observant eyes cataloged all these things. But
well, I think that's the testament that she was actually measuring the stars, and just being observant and noticing that eraser smudge. Probably could have gone through 10 other people and they wouldn't have seen it there. So
yeah, some pretty amazing discoveries, just from observation, for sure. Yep, thanks, Dave. So tonight, I think we have a bit of a kind of a mishmash of stuff. I think we had some hopes of maybe streaming the planets tonight, but I think the weather's not cooperating with us tonight. So Dan, I know you've been busy. You have some lagoon pictures queued up potentially.
Oh yeah, I can toss out to that. So everybody, just to preface this, imaging from downtown is not for the faint of heart. So this is more an exercise in insanity than anything else, but we'll see what you think. So actually, yeah, I'll go to the lagoon shot first. So this was I cracked this off over the last couple weeks, just off of my condo balcony. Again, not ideal observing conditions, but it's looking at the Lagoon Nebula for the couple hours I had each night before it went behind a building. And I think that this is just over 10 hours of exposure. So because I only had those small windows of time between it getting dark enough to take data and then get that hour and a half in and go, I had to work with it. This is the Lagoon Nebula, as I mentioned. I think it's about 6,500 light years away. It's affectionately known as Messier 8, just a lovely catalog number. And this one's a stellar nursery. So it's an emission nebula, which means that all of the different features in the gas that you're seeing are being excited by the light from nearby stars. And you're then getting a response where those clouds of gas and dust are then emitting their own light in return. This is predictable because of the way that quantum physics works, which means that that light will always be emitted at the same wavelength when that excitation process happens. And so with this, what you're seeing is the blue as oxygen gas. All throughout is hydrogen signal, and then the orange and golden pieces are largely sulfur too. So the second emission line is sulfur, with some dark nebula and other blotches in between. But the other one that I took, and this is hot off the presses because I just did it last night, is on M31. And we have had a monthly challenge here, so I decided to make the best of it and go not just for M31, which is the Andromeda Galaxy, but for something called Integrated Flux Nebula at the same time, which is this feature off here on the right, if this is coming through on my screen. And so this is gas within our own Milky Way that isn't lit up by anything. So going back to that question about what it would look like as you went closer and closer to Andromeda or another galaxy, well, what's interesting is that there's all this material that normally you can't see. And what this feature is over here on the right is this unilluminated gas. And why it's called integrated flux is because the only thing lighting it up is the combined brightness of all of the stars in our own galaxy. This is something that wasn't discovered, or it didn't have a name coined for it anyway until about 2001, because professional telescopes their time's far too precious to go looking after faint patches of the sky with nothing there to try and pick out these dim features. You have to be answering a scientific question. But then astronomers came along and they had equipment and apparently near infinite patience to go after features like this. And so we've been able to tease it out and see a bit more about it. And I guess the point I'm making is that no matter how close you get to a system like this, the closer you get, the dirtier things are going to be. There's just going to be material that you didn't even know. I mean, this took hours to just pull out. In most pictures, none of this would be visible. And so even the blackest patch of the sky has something to it in almost every case. And this is just a good example of that. But yeah, that was my project last night.
Yeah, Dan, we talked a little bit tonight about finding darker skies to work in. Now, you're not in a really dark area, relatively dark, but how are you surmounting that?
With this one, it's just taking a lot of shots and then stacking them together. In this case, it was 244 frames. So there were quite a few, but they're only 30-second frames. This is just 2 hours. Honestly, what I was really doing in this case was using a very particular lens I have. So this is a off-the-shelf consumer-grade camera lens and a consumer-grade camera. But it's a very unique combination that it's very fast. So even though it's a off-the-shelf lens, the stars are pretty good. They only fall apart a little bit out in the corners. And that allows me to shoot at or near what we call the sky fog limit, or the limit of how much data you can get into any one frame within about 30 seconds from our sites here in Victoria. So if you're riding right along the limit of what you're able to accomplish with any frame, and you bring the time that you need to do that from an order of minutes down to an order of seconds, you're able to still get past light pollution and other issues like that by stacking or combining all the frames together.
Yeah, so your trick is to get really high signal on top
really
of the
high
noise.
signal.
Yeah. Yeah.
It's one of the few ways to get past light pollution. But I think those are the two big ones that I've done recently.
Okay, sounds good. Brock, are you still here tonight? Did you have
I'm
anything
here.
to show?
Yeah, I could show. I've actually had the last couple of weeks, I've done a number of shots. So.
Okay, let's see what you got.
Sure. Can you guys see the Iris Nebula?
Ah, yeah, very nice.
I think I might have shown this. This I actually shot this on the night of the previous. No, I wouldn't have shown this because it would have taken it that night. So this was 2 weeks ago, Saturday.
Yeah, I see a little bit of dark stuff there. Dark nebula.
Yeah, there's the Iris Nebula has it's a reflection nebula from a star, and the dust that's obviously close enough there is reflecting light, but then there's a lot of dust further out, and that's essentially a dark nebula. And I didn't have enough time to really make that stand out. If I'd have doubled the exposure and I had another night on it, I probably could have made it look better, but I wanted to move on to other targets, but pretty happy with it.
Yeah, you've got some nice star color there as well. There's a really nice reddish star up at the top.
Yeah, there's actually a number. This one had a particularly good star colors, came out well, both on the bluish younger and reddish older stars. So,
do you spend a lot of time to get accurate star coloring?
A little bit, yeah. I mean, it's definitely something I like to get if I can, for sure.
Very nice.
Thanks. I also brought out my solar filter because I had heard there were some sunspots. So I was able, I don't know if those are visible, but can you guys see the sun?
Yeah, I do. So this is a white light filter, right?
It's a white light filter. Yeah, it's just just one from same company you have. What's that?
Thousand Oaks.
Thousand Oaks, yes.
Yeah, Thousand Oaks is one of the classic filters. I understand they've stopped making the glass now.
Yes,
so they're only making film.
Mine is film.
Yeah, mine's still glass.
And then I got out and did a shot of the Heart Nebula.
Oh, very nice.
And that's a nice emission nebula.
Yeah, this guy's got a partner. They call it Heart and Soul, I guess.
Yes. Yeah. I didn't go wide enough to get both of them in frame, but this is up in Perseus.
Yeah, definitely cardioid shaped.
Dan, was it you that did the Heart and Soul Nebula a little while with both of them?
Maybe, but I think that I shot the same one. This is a really nice result, Brock. Really great shot. Last fall maybe, but
yeah.
Again, this is great. Was this with your ASCAR?
This was with my ASCAR, and it was one of the first shots I got with my new camera as well.
Ooh, very nice.
Well, I guess all of these would have been with my new camera. But yeah.
Yeah. Does anybody know anything about some of the features here? Like I'm looking at that concentration of stars. It's almost like an open cluster in the middle.
Yeah, I think it is an open cluster. It's kind of like, I think the next one is actually another.
The winds from that cluster is what's blowing the gas out in that shape.
All right.
Yes, this one was probably a stellar nursery that's a little further along than something like the Orion Nebula.
Yeah.
And if I remember, there's some very nice features in both oxygen and sulfur right in there at the center. The rest of it's a little bit dull. It was kind of hydrogen dominant, but right at the core, you could see it.
Yeah, I think what's really nice about this picture is there seems to be this kind of folding or concentration of probably the H alpha, I guess, as it gets concentrated along the rim or along the edges of it, which is kind of interesting.
Yeah, that would be like the ionization front. Is it the UV light from those new stars in the center reaches the gas that's been hidden from them as it gets blown away by the winds.
Oh, does that create that kind of rim-like effect, Aaron?
Yeah. Like with the Orion Nebula, what you're seeing is sort of a bowl shape like that. In this case, it's probably that the gas cloud was, I don't know, a bit thinner in one direction. And so it's blown out the front and back, or that ionization is too thin for us to see anymore. And we're seeing the edges of it sideways, where we're seeing through a larger column of gas that's ionized.
Aaron, any idea what that stuff is up at the top corner, the top left corner?
Probably another knot of star formation that may have been more deeply embedded in gas. So that one would be more like the Orion Nebula, where it's just like a cavity inside that's been blown out, that's just open on one side where it's reached the edge of the gas cloud.
Okay.
And that's why it's still got some filaments in front of it.
Isn't that the Fishhead Nebula or something? Just that one.
I don't know. Not sure.
That what that one is? There are too many names to remember. Just for the audience, one of the good things about the way that astronomers name things is that they tend to actually resemble whatever you're looking at. So the Ring Nebula, spoiler, it looks like a ring.
Looks like a ring.
For certain definitions of resemble, yes.
Yeah.
Yeah, there's definitely common names, which are often very descriptive. And then there are the catalog names. So you kind of have to know quite a bit, actually. There's a lot of cross-naming of things across catalogs.
Yeah. This is IC 1805, if anyone wants the catalog.
Exactly. Yeah, exactly.
And objects like this that are a bit larger tend to have multiple names for different regions or parts within the object.
Right. The next one is also an open cluster that's exciting a bunch of gas.
Yes.
And this is the Eagle Nebula, which is M16. So this, I actually did this one just a few days after. So
yeah, so a lot of people will know this one for the central area, which is the Pillars of Creation.
Yes.
With a slightly different color palette.
Yeah.
Just to reference back to the analogy of the ants trying to piece together the life cycle of a human, like these two pictures that we've just seen would be sort of like right next to each other. This would be like a baby picture next to like a 2-year-old in terms of stellar ages. So this one would be the baby picture. So this is the nursery where it's just emerging out of the gas cloud. And then the next one would be the 2-year-old picture where it's like blown away a bunch of the gas around it, but you're still seeing some remnants further out.
I just had a great idea for a photo op, Aaron. Maybe we should have like a family picture.
Yeah.
You could probably group a bunch of things together.
Each one wearing a different T-shirt with a different nebula on it.
Oh, that'd be fun. Yeah. Can we recruit the Duggars?
Could I ask Ruhi a question? Is Ruhi still there?
I don't know.
I'm still here.
Oh, yeah, she is.
You are. Ruhi, is what you do when you talked about protostars, it like is this kind of what you look at?
I wish it looked as pretty as this. So what I look at is with ALMA. So we're looking with like near infrared light. I'm assuming this is probably optical. So it definitely doesn't look as pretty as this. So what we see, because our protostars are deeply embedded, is we don't see the star itself, because none of that optical light can escape the cloud. It keeps getting reabsorbed. And the only thing that we can see is it's near infrared. So we see like the general area of where the star is. And then what I actually study are these considerably massive outflows that stretch out further from the star, that are ionized from the star itself and shot out. So those are, it's like just the brighter area of the star. But I would love to see this, but I don't.
Well, the streaks in the background of the Horsehead Nebula, if you, I won't pull it up again, but there are streaks back there, and I read that those are streaks from protostars.
Yeah.
Yeah, protostars are definitely a turbulent environment that's kind of throwing everything around, throwing clouds of dust and gas around, throwing out outflows. So you're definitely going to have a lot of streaks when you're around them.
So Rui, are you playing normally just dealing with data as opposed to imagery?
So what I do is I just go through the ALMA archive, and I have to reduce all the data into an image and then self-calibrate the image itself, so we get out a lot of that noise. And then after that, then I can actually work with the data from the image. So I have to first create it and then work with it.
Yeah, I'm doing a little bit of photometry right now, and I'm kind of learning all about calibration being the thing, right?
Yeah, it's
getting all the noise out.
For sure. Yeah, it's hard. It's hard.
Yeah,
especially since I work with CASA to do all of my work, and a lot of the objects I'm working with were taken years ago, and they're just sitting in the archive waiting for someone to do something with them. But they use older versions of CASA, and we're trying to make it so it works with newer versions of CASA that do newer features, and it cleans it way better. But you have to rewrite all of the scripts. Like, the language is completely different, even though they're just different versions of the same program. So it's
say you're working on one data set. How long does that take you?
Oh, that's a good question. So one data set is normally about 150 to 200 gigs. So running the image script can take about an hour, the self-cal script a little longer. But once I actually start working with the data, it doesn't take very long if you're just using a Python script. It goes through it pretty fast because I'm sectioning out the data and what I actually need. So when I'm doing the actual science behind it, not very long. Actually creating the image,
so you kind of you define a small region to work in.
Exactly.
Right?
Yeah.
Do you, I was just going to ask, do you run that on like a AstroServe or whatever, or does this like?
Yeah, I use what is it called? I can't remember the name of it.
You certainly don't run this on your own computer, right?
Oh my goodness, no. I do just the local Python scripts on my own computer. I do none of the imaging on my computer. I forgot the name of the server, but UVic is with them, and they have every single version of CASA on there. So it's just like a virtual server, because I can't run the older versions of CASA on my computer. It's just not, it doesn't work. So we just have a big old server that they let me do all my work on. Thank goodness, and save all of those gigs of data on, because I don't want to put that online.
Thank goodness for remote computing.
It's been a lifesaver.
So Ruhi, what would this look like if we looked at it in ALMA?
Okay, hold your question. Let me see if I can dig up something that I worked on. And then
there is an infrared shot of the pillars of creation that Hubble took. But I'll show you my last picture, and then we can.
Okay,
look
sure.
at that
sorry.
infrared version.
I'm interrupting.
This is the final shot, I think, that I took, and this is
the ring.
It's actually the Helix Nebula.
Oh,
Helix, yeah.
It's a lot like the Ring Nebula, but it's like 3 times closer and twice the diameter.
Yeah, there's more stars in the center of this one.
That's just magnificent.
Yeah.
It's a beautiful shot. I wasn't even sure we were even able to see it from the Northern Hemisphere. So
it's got like an outer ring as well, Brock. I've never seen that before. There's
a faint outer ring here. If I could get some more hours on it, I was kind of hoping to reshoot it. Last night, I should have done it again last night. I thought the forecast and the satellite just made me hesitate, and I didn't really want to. It said there could have been showers in the morning. I didn't really want to go to bed thinking that my stuff would be sitting out there in the rain. So
is that got narrowband in it, Brock?
No, it's just one shot color with the CLS CCD filter.
But if you got hydrogen alpha and added it to it, you would get that outer ring.
Oh, for sure. Yeah. My new filter just arrived the other day, and I've been hoping to use it, but as soon as it arrived, the clouds came. I have that NBZ, so that has a nice narrow hydrogen alpha band. So it should give me a much better, if I extend I could do a lot longer exposure because I dampen the star brightness with the narrower band passes, and maybe do 5 or 6 minute exposures of it, and probably pull out that extra ring.
I wonder if that outer ring might be from the helium flash. I wonder if do Do you know the age of this planetary nebula? Like, could we trace that back?
I don't know the age.
Well, if it's like the Ring Nebula, it's nitrogen and helium on the inside and hydrogen on the furthest outside, I think.
Yeah.
What rings those are.
Mm-hmm. It's a beautiful target, though.
Ruhi, were you?
I am ready to go. Yeah, I'm good
Okay.
to go.
Okay, so let's hear from Ruhi, and then I've got one last image from David, but let's hear from Ruhi first.
For sure. Can someone give me sharing permission?
Oh, there was this one too that we. Yeah, okay, sorry.
Sorry.
That's okay. We'll talk about that one another time. Let me unshare.
Yeah, go ahead, Ruhi.
I'm just waiting. Oh, there we go. We got it. Okay. So I'm just gonna share my screen real quick. Okay, can everyone see this? No, you can't. Hold on. Just throw this here. Okay, so this is BHR 179, if I got the number right. So this is what I actually see when I create the image. Because I used it with the older CASA version. This isn't the newer CASA version. This isn't the nice one. So it's really noisy, but you can definitely see these large outflows. So what these are two protostars, which are right here and right here. And these are the northern outflows. I also have a southern outflow one, which will have basically a mirror image of the same thing, just flip the opposite way. You just take them at different velocities. So this is what I see as an image. That's just what I work with. And then what I did is the prettier thing that I did.
That's a tiny section of the sky, isn't it?
Yeah,
Ruhi?
it is very small.
Yeah.
I think we were looking at things within 3 to 4 arc seconds to find these images.
Yeah,
tiny. And then what I do normally is, this just made it prettier to look at, so that's what I thought I'd show you, is I created these RGB images of these outflows. So what I did is what I showed you was a moment map. So it took the average of the velocities of the outflows and kind of just made a pretty picture for you to look at to kind of see what it looked like stagnant. So what I did is I took the higher velocities of each outflow and kind of put them together. So this is the highest velocity towards the lower velocity. So as you go to the lower velocities, you're going to see a lot more of the outflow. And that's where you get these like pretty magnificent large things. So you can see how big these outflows are to their stars. Their stars, even though they're literal stars, are so small compared to these jets of just ionized gas that they're shooting out of them.
That's amazing.
Yeah, they're fun.
So just to be clear, you're basically saying that there's more slow outflow and just a bit of fast outflow, right?
Yeah, at least for this one specifically. For BHR, yeah, that is what happened here.
I'm glad you asked the question, Lori.
Yeah, Lori, thank you for letting me boast about my research. Thank you.
Yeah, and for context, like this image would be like inside one of those darker granules in a star-forming region. So this might be like one tiny piece of one of those pillars of creation, like zoomed in really, really tight on it, rather than looking at the whole star-forming region as a whole.
Exactly. They're very, very small compared to their larger areas in their nebulae. Okay,
Yeah,
cool.
beautiful.
All right, I'll stop sharing.
All right, so we're getting close to the end of the evening, and I know it's sad to go, but David is going to close us out with an image of the Andromeda Galaxy.
Yes, as long as I pull the right one up here. So this picture was just it was my first mosaic. What I wanted is to capture a fairly decent resolution image of the Andromeda Galaxy, which you see here. But I couldn't capture it all in one telescope, so one image. So I actually took two images, the left side and the right side, and stitched them together. And I had shown this at a recent astronomy cafe, and I got the difficult question. And you can sort of see when you zoom in here, these little blue dots, were they stars? And I had to go back and say, well, I really don't know. They kind of look like stars, but I've been told that we can't really see stars outside of the Milky Way. All the other stars you see in this image, all the other dots and stuff are basically stars in the Milky Way. So I wanted to find an answer to that, and rather than just look it up, I decided to get a larger telescope and focus in on a specific area. If I can go back and pull up. Where is it? Here it is. So I actually
it's close up.
Took a, let me get it full screen. So I actually took a close-up of it, and indeed satisfied to myself that, in fact, again, with a backyard telescope, it's a fairly big backyard telescope, but still a backyard telescope, I could actually see stars that aren't in the Milky Way. And
are they in front or behind?
So the reason why you can't, so this is towards the edge of the Andromeda galaxy, so in the outer part of the arms. When you go to the inner part of the arms, there's such a concentration of light and dust in the background that you can't see the individual stars in amongst themselves. When the star concentration goes down and you get a little background dust, or even seeing through the galaxy itself, that's when we pick up the stars. The second point is these blue stars that you see out here, particularly in the center area of the diagram here, they're about the 25 or greater solar masses. Mm-hmm. So they're very large, young, bright, fast burning stars. And it's that brightness that allows us to actually capture them. Mm-hmm. And Brock and I have actually been playing around, and he's got a good image where you can actually see stars in the Triangulum galaxy too. So it's not too much further away than Andromeda, but so we can even capture stars in other galaxies and resolve them through amateur equipment.
Sounds like this is going to be a work in progress.
Yeah, there is a bit of a work in progress.
Yeah, wonderful.
So
well, thank you so much, everyone. I just wanted to thank the crew from this season, for all the great photos, and so being able to just chat about them with the group. So it's been a wonderful season.
All right, so that
thanks everyone.
Does it. Yeah, go ahead, Aaron.
Yeah, thank you everyone for your fantastic images, and thanks again to Janeane and Tony for telling us about the Nanaimo Astronomy Society, and Margie, who I think has already gone off to bed, for telling us about women in astronomy. Dan and Ruhi again for Ask an Astronomer. It's been an amazing evening. Once again, thank you all, and clear skies everyone, and please join us in a few weeks for our next star party. It should be up on the events page of the Center of the Universe website very soon.
Very soon. It's not quite yet. And I think, Lori, you might know this. Is it going to be the AGM next time?
Yes, I was just going to say that it's the annual general meeting for the Friends of the DAO. So if you are a member, then you can definitely register and vote for all the really exciting things that happen at an AGM, like financial statements. But if you aren't, then we're going to be having a speaker speaker. We're just confirming the person that we're going to get coming in, and we hope that it's going to be a woman. That will be our speaker for our annual meeting, and then we'll also have some other things that are happening that night. And it's October the 30th, so it's still a little bit farther away. And then the next one will be November the 20th. And then the last one for the season up until Christmas will be December the 18th, which will be our third annual winter solstice party. So we'll be able to do that. And maybe by then we might be able to see each other, but we don't know. We'll see. Thanks everybody.
That would be fantastic. Hugs and hot chocolate all around.
Aaron for being the person who looks after everything, Amy for being the host, Dan for being on the Plaskett whenever we can get on the Plaskett, and David, you have just been phenomenal in keeping everything going. So, and Ruhi, thanks everybody to the people at UVic for helping all summer long. You guys have been fantastic.
Big applause for them.
Yes. And Calvin.
Oh yeah.
For keeping us all going. Yay! Yeah.
Making sure all of this works.
Yeah.
Okay. We'll see you on the 30th, everybody. Thank you.
Good night, everybody.
Bye-bye.
Take care. Clear skies.